Time, we'll start. Welcome everybody, thank you for coming along to my talk. This is eBy Packet Filter, eBPF for security monitoring, or as it could otherwise be called, eBPF, all of your wildest dreams will come true, terms and conditions apply, which sort of reflects the way that I feel about eBPF at the moment. But we'll get onto some of the good stuff that we can do with it in a second. Cool. So a little bit about me, first of all. I am John McAfee, wearing a wig, trying to escape on a boat somewhere, as somebody at BSides last night rather uncharitably said, since I've cut my hair a bit shorter. But my name is James Ogden, otherwise sometimes known as Linux Thor. You find me here on GitHub and on Twitter as well. Don't tend to be super high volume on either platform, but occasionally put things on there that I find maybe mildly interesting. In my day job, I'm a tech lead for security engineering at Sky Betting and Gaming. So in security engineering, we look after all the kind of security tooling that protects the platform, so things like IDS, multi-factor authentication, session recording, a lot of different security tools. And a big part of what we do is to feed data into our SIM tool so that our security operations guys can monitor that. They can have a look at graphs and alerts and so forth. So I'm very interested in ways that we can either get more data, data that might not have been available before, or ways that we can get the same data but much more easily without having to jump through perhaps so many hoops. So we'll move on to the technology that we'll be talking about, which is eBPF. Who here has heard of eBPF? It's cool. And who here has used eBPF before? A couple of people here have used it, somebody else over there as well. And who has heard of it, maybe is interested, or has never heard of it and is maybe interested? Would that be sort of the rest of you? Is there anybody who is not at all from a Linux background? Okay, cool. So hopefully it's going to address what most people might want to get out of the talk. The people that have used it before, I'm not sure there's going to be anything super new, but I can kind of show you one or two things that I've been playing with it. So in terms of what I can hope for you to get out of the talk, we're going to kind of cover what it is, who might use it, what are the limitations, some of the limitations, and then we'll have some demos at the end to actually show you it in use. This isn't a running order as such, but hopefully by the end you might kind of get a feel for this and then decide if it's something that you want to take away and maybe have a bit more of a play with. So I'll show you one or two ways that you can get started with it really quickly. So, eBPF. This is a Linux thing. Sorry, I've got a bit of a sore throat this week. It's a Linux thing. It's built into the Linux kernel. You do need perhaps a bit of a newer Linux kernel. You're probably going to get the best results from having the newest kernel that you can find, I think is a fair way to put it. So if you have something like maybe a 4.15, which I believe comes with Ubuntu long-term support, that would be great. They have packages in their repositories for working with BPF. I'll come on to that in a second. If you have a slightly older kernel, maybe back to maybe 4.3-ish or so, you're probably more or less okay, but you might find one or two things are not there yet. So if you want to have a play with this, you probably want to have the kind of newest kernel that you can get your hands on. So, a little bit about what it is. It's a tracing framework, essentially, built into the kernel. So you can write programs which are compiled into a bytecode and then loaded into a virtual machine. And you can do what I think are some interesting things with those. So we have a quote here from Ingo Molnar, who's one of the Linux kernel developers, as you might know. So when eBPF kind of first came around, or eBPF in conjunction with kprobes, which I'll come on to as well, this was a quote, and I think this kind of sums it up quite well, what it is and what it does. Also, somebody else gets to say this bit, which I would be a little bit perhaps hesitant to say. So we'll let somebody else say that part, and then we can just put it up there. And it's not me that actually has to say it can never crash, never interfere with the kernel negatively. But it's less likely to cause a problem than other things that we might have used in the past for similar jobs, such as loading in kind of custom kernel modules that might be hooking things in various ways. So it's much safer. And we'll go over some of what I think are use cases for eBPF. So this is just my own opinion. You might have different ideas for what you can do with it. But I imagine that it could be useful for blue teamers. So this is a term that's become a little bit overloaded, perhaps a little bit meaningless with time. But I'm talking about kind of the good guys, the people that are deploying tools into the network and they're monitoring for threats. Maybe it's as part of an exercise of some sort, a red team, blue team exercise, or it's just your kind of general day-to-day role. We have blue teamer there. And then perhaps a kind of a subset of blue teamers, or maybe a slightly different discipline, are security operations folks, as I mentioned before. So these are the people that sit in maybe your security operations center, sitting in front of all these interesting graphs and alerts and things like that have been produced for them. And then maybe they're taking some action for you. Maybe they're performing some kind of blocking. But as with many things in security, they need data. Security is, as a very wise person once said, whose name has escaped me now, but security is kind of a data-driven problem. So the more data you have, perhaps the better your posture is, if it's the right kind of data. Then another use case that we can imagine for eBPF is testers. So anybody who is poking a system, they're performing some kind of test, and they'd like to get a bit of extra information out of there about what's going on. So eBPF can be really good in that case as well. And slightly related to the testers, we have hackers in the old school sense, in the old hacker versus cracker thing. Don't worry if you're too young to know that, or it's passed you by. It was a holy war that was fought many years ago and wasn't very interesting to anyone. Okay, so a little bit of history of BPF. So we're talking about eBPF, but first of all, we have to kind of know what BPF is. So BPF is Berkeley Packet Filter, old Berkeley Packet Filter from like 1992 or thereabouts. I won't ask for a show of hands of anybody who wasn't even born then, but I've got my suspicions about one or two people I can see in the room. But it was originally used for one or two different use cases. So this has become known now with eBPF as cBPF or classic BPF, but in the past was always just Berkeley Packet Filter. So what we have with classic BPF is a very simple virtual machine, just has a couple of registers, has a little bit of scratch space there, and then we can load up some bytecode to perform different kinds of operations. And that piece of documentation there on the right is from one of the Linux kernel documentation files. And I put it up there because it's such a short thing, but it kind of summarizes almost entirely what the architecture is of the classic BPF virtual machine. It's super simple. In evolutionary terms, we're we've got up, we're staggering around, but we haven't yet worked out how to pick up a rock and bash things over the head. So we can still do some interesting things here. So I'm guessing maybe most of you have used TCP dump in the past. Seeing nods in the room. So that uses Berkeley Packet Filter, BPF. So you can pass the -d flag on your TCP dump command, and then it will print you out a dump of the BPF code there. So I've done it there for a couple of different TCP dump expressions. So we have port 80 and port 81. So you can see there, I think on line 7 and 17, 50 on one has become 51 on the other. So you can kind of get maybe a small feel for what's going on there. So moving on to eBPF. What is eBPF? eBPF is exciting BPF. It's not. It's extended BPF. And what we have here is another virtual machine, but it's a little bit more advanced this time. So we have 10 registers, we have a stack, it's a small stack, 512 bytes, and then we have this concept of maps. And maps are something that we can load data into, we can share that with user space. But don't get too excited yet. We're only a little bit further along in the evolution. We've picked up a rock, we've sharpened it, we're bashing each other over the head, so we're doing interesting things, but it's not yet super advanced, but we can do some very interesting things. So eBPF is something that applies in a number of places. The ones that I'm going to be talking about are K-probes. What K-probes are, and K-probes, by the way, are older than eBPF. You could use K-probes in the past, but you had to load a module and then you had to inject your K-probe that way. And what we have is the ability to be called whenever a function in the kernel is called. So we attach a K-probe to a particular kernel function, that gets called, we're called first, and then we can extract some information from that. If that makes sense to everyone, hopefully it does. We also have U-probes, and U-probes are like K-probes, but we can use these in user space. So functions within user space applications, we can attach our probe to, and we can also do this with libraries as well. So system-wide, we can do something like libc, for example. We can attach a uprobe to a particular function in there, and then whenever that gets called, our uprobe will be called as well first. And then as well as those two, we have krep probes. Krep probes are like K-probes, but they get attached at the end of a function. So just at the end will be called, and then we'll have the opportunity to have a look and see what the return value is, which is very useful. And we have the equivalent in user space as well. So we have quite a bit of power there in terms of where we want to attach our probe. And as it said before, this is all eBPF bytecode running in a sandbox or a VM. So there's little danger that we're going to cause too much harm. You can crash it, but it takes a bit of work. I try very hard. So how to use it, how to get started with it. You can potentially write your own eBPF bytecode in some way, but it'll be much easier to use BCC, which is the BPF compiler collection. This makes it very easy to write eBPF code in C and Python. I don't mean C or Python, it's C and Python together. So it's very often Python with a big lump of C in the middle of it. Yeah, it gets kind of interesting. So to look at a really simple example there, what we've done here, so we've got our kind of Python wrapper, and then we have a little bit of C code in the middle. So we're going to be doing a kprobe. We're going to be attaching it to sysmkdir. So that gets the function that's called in the kernel for making directories. And then we can see just there, we have the PT regs, which is otherwise sometimes known as the context. So whenever our probe fires, first argument that will be given is a structure describing what the registers are looking like currently, which may be useful for some things. And then also, we've gone. Crazy. Okay, that's better. So then we'll also have the kind of signature of the function there as well. So mkdir takes path name and a mode argument, and then with our BPF trace print k there, we'll be able to say mkdir has been called, and then we can exit from our probe. We can return 0 there. And then you can see underneath the result of running this. So when we run this, as root, you need to be root or have cap sysadmin in order to use eBPF. But when we run that, whenever we make a directory system-wide, our kprobe is called, and then we can potentially even extract some information from there. So we can take the argument there that is the path name, and then we can perhaps print it out. So the thing that you can see there with the BPF trace print k is a kind of very quick and dirty way to get some output from your eBPF program. This isn't really ideal. This does allow you to do some kind of quick prototyping and that kind of thing. But whenever you're using BPF trace print k, you're using, it appears under the under /sys as a file there, and then that's shared. So every thing that's using this across the system is all trying to share the same file, essentially it is. So you might find that if you have two of them running together and they're both using BPF trace print k, you might not get the output that you expect where you expect it. You may also find that if things terminate without it having read everything from there, then the next time you fire something up, you'll get essentially some output that's still waiting from the last time, which isn't great. So the way that you're supposed to do it, and it does add a little bit of complexity, is to use, so if you see there, we have the structure there that we've defined. So what we're going to do this time is create one of these BPF per CPU arrays, and then we can copy data into there, and then we can share it with user space with the maps. So it has added a little bit of complexity in the C code. I've actually split it out into a separate file. I'll come on to the options for what to do there in a second. But I think it is a bit cleaner to do it that way. It's just a matter of preference. Unless you're doing some kind of a demo or a teaching exercise, it can be useful to have everything all together. But I like to separate them out if I can. But then also, if we look on the Python side, there's a little bit of extra complexity there as well, as we've had to introduce Python C types, which is a little bit clunky to work with, in my opinion. Obviously, it's just a matter of opinion. But things there, like when we have to cast, it's kind of a bit more clunky than we'd hope it to be. But then this allows us to run many of these programs without them ever interfering with each other. So that's the reason for a little bit of extra complexity there. So as I mentioned, you can load your C code from a separate file. You can either do it in the top way there. So we are loading that in, and then we're getting it as a string. We might want to do that because we may wish to rewrite it in some fashion. We might want to insert some extra bits and pieces in there. Or if we're happy that our C code is all that it can be, then we can just BPF with the source file there and load it in. And it works like magic. Not quite. It doesn't quite work like magic. It works by essentially patching the function and then jumping into our code. So there's nothing too magic there at all. That might be a little bit of an allusion to time of check, time of use vulnerabilities that perhaps you could run into if you're not careful about what you're doing. So the next thing to mention is the eBPF verifier. So as I said, your code is loaded into a VM, into a sandbox, and then it is subject to inspection by the verifier. And it can feel a little bit frustrating sometimes when you're trying to get something to work and some of the errors are not always easy to understand at first. You can kind of get a feel for them over time. There are strange things that can happen that I've seen as well, where maybe the order of things can matter, even if it looks like it shouldn't. Sometimes you can find that things aren't quite working the way that they should, and by making what appear to be small, fairly cosmetic changes, often in the C code, you can find that it's all of a sudden working, which can be a little frustrating. So if we have a look at this here, so I've deliberately put some broken eBPF code in here. I think what I was trying to do was to copy more bytes into a stack-based buffer than was available, so I was trying to overflow the buffer, and the verifier has said no. The error is reasonably okay there. It's saying invalid stack type, giving us an offset, and it's saying the access size 400. I think I was trying to copy 400 bytes into 4 bytes there. So that's kind of fairly helpful. It does take a little bit of thinking about it at first to work out what it's telling you. But then you can get other ones like this, the back edge from instruction 33 to 23. So what I did here was to deliberately introduce a loop from which I wasn't exiting. So that's another thing that it will check for. So it does have a jump forward and a jump back. So you can, a simple for loop or something is something that you can have. But if you get into a loop that you aren't getting out of, it will say no. So the way the verifier works is to kind of do modeling of the code and work out where it's going and whether any of the operations will violate its own inbuilt set of rules. So it has other things as well, like accessing memory that doesn't belong to you, as well if the size of the program exceeds a certain number of instructions, then also it will be a problem. So, back onto this thing of monitoring. Monitoring very often is, rightly or wrongly, unfortunately, a necessary evil, that it's driven from logs. Well, logs are okay. You can get some good stuff from logs, but sometimes you end up having to read the data in, chop it up, and that kind of thing. And of course, logs will only have the data in that the developer thought was useful and thought somebody might be interested in. And another problem with logs is sometimes you have to turn on some sort of debug mode to get exactly the level of logging that you would want, even though maybe you don't want the whole fire hose of everything to do with the application's internal state. You maybe want something related to a library it's calling or similar information. So it might be that the logs they don't have the information for you. And even if they do have the information, you do have to do this process of taking some logs from somewhere. I've deliberately chosen Apache. A colleague of mine who's doing a talk right now, track 1, Glenn, he likes to say that security isn't always the Project Zero shit. And I think that's very true. For some people it is, and browser exploitation and everything like that is wonderful. But for a lot of people, and myself included, security is probably just taking some logs or events or data from somewhere and then putting it somewhere else where people can use it. So in this case, we have Apache, which is writing its logs to disk, and then we imagine that we are perhaps tailing them, and then we have this thing in the middle, which is represented by the meat grinder, and that's all the nasty stuff that you have to do with it. That's how the sausage is made. When you have regular expressions in there, you have all kinds of different things to transform, munge the data. Maybe you use Splunk and, you don't quite have deep enough pockets to send all the data into it that you want. So you have to start trying to filter stuff out that doesn't look interesting or put stuff in that does appear to be interesting. And eventually the aim is to get it to your security operations guys, perhaps in some kind of security operations center, and they may wish to look at graphs and that kind of thing, or we may want to produce alerts from there for people, perhaps who own these systems, to take some action. So, wouldn't it be better if we could use the magic fist glove of eBPF to reach in there, take what we want, and give it directly, or more or less directly via a little detour, to the security operations people or whoever it is that might be interested in this data, and then also produce the alerts. So we want to extract the good stuff and profit easily, without too much fuss, without too much messing around with regular expressions and that kind of thing. Just get the good stuff out and make money or something. Cool. So I'll move on to a few demos so you can see this for yourself, and hopefully kind of cover a little bit of what my workflow is in doing this kind of stuff, how I find what might be interesting. Oh, this is going to be fun. Can I... Hello. Okay, this is going to be really fun. Right, I'm going to blow this up because I've not got quite the screen mirroring that I want, so I'm going to have to kind of lean around the corner to see what I'm doing. So hopefully that's the worst thing that happens with the demo, but we shall see. Cool. So when I showed the screenshots before, I was talking about using this with the... where's my mouse pointer? Is it in the right sort of place? Oh, there we go. I was talking about having a look for McDir calls. So the easiest way that we can get started with this. So I've installed on here BCC, and I also have the tools, the examples that come with it. So I have a very, very helpful tool installed here called Trace, or I think as it's called on here, Trace BPF CC. Yep. So what we want to do, first of all, is just do a real simple kprobe, and we're looking for our sysmcdir. Okay, so that's running. So if I... So we can see that that's being called. Cool, so I'll do it again. Okay, that's from earlier when I was practicing, but not to worry. You can see that it's been called anyway. So we might be interested to have a look and see what the argument is that we are calling it with. So we can do this, something like it. Yep. So now I'm calling this again, but now with the kprobe, we're extracting the argument there so we can see what directory we were trying to make, which is potentially useful. And we can see this system-wide. So any process now which is making a directory, we can see that. The other thing that we can do as well is to potentially stack one or two of these together. So we've done our trace there. So we can also do this. That's just about right. Okay, so what we've done there is to attach a kprobe to sysmcdir, so the thing within the kernel that's responsible for the mcdir syscall, and then also we've attached one to mcdir in libc. So any application dynamically linked which is calling mcdir there will pick that up. So we don't need to launch the programs in a special way running under, say, ptrace or something like that. We just ask the kernel to tell us whenever anything is doing these operations, and then our code gets called there. So this is kind of the way that I normally start off prototyping this kind of stuff. I have an idea that I might be interested to have a look at something, so then I'll use trace to kind of attach to a few different points and see, is it firing when I expect it to? Am I seeing the right kind of information? Without kind of going and reading any source code or anything yet, that can come a bit later on to work out perhaps exactly what the function's arguments are that it's expecting. But that's just a really simple way to kind of go, is this interesting or is this not interesting? Is this worth pursuing a little bit further? So when I have something that maybe looks interesting like this, yep, so I can then progress to doing a bit of Python. No, Vim, that'd be alright. So that's the example that we saw before on the slide. So that's a really simple version of it. And then I've got also the example there with the string, the argument for the path name. And then if this is all kind of looking good and interesting and like something that's worth pursuing a little bit further, then I'll maybe work up to something like the other example there. So we've got our so that's our C code, as we saw on the slide before. I'll just move that down a little bit if you want to see that. And then it has its corresponding bit of Python as well. So by now that's maybe looking more of a kind of a useful thing that could be used for, found myself about to say use cases, but then I realised I said use far too many times there. Cool. So is that kind of clear for everybody? Do you understand? Any questions? Do shout out if you have any questions as we go along. I hope there'll be some time at the end, but just give me a wave if you have something and we can come to you right away and deal with it while it's fresh. Cool. So have I still got my thing in focus?
Making directories isn't the first thing that somebody's going to do, though, is it?
Not necessarily, but it makes a good example just for the kind of the hello world example here.
And you can like trigger it easily. Yeah, I mean, it's good to use something like mcdir for an example because it won't be being called all the time. So sometimes people might use open or something like that. But often a lot of stuff is calling open. So mcdir is maybe not the best real world type of example of what a real attacker might do. But it's a good maybe place to get started and have a look. But the next example that we have here. So what we're going to do here, just see if I've got the right one open there. Yep, cool. So we'll go back to our example of Apache web server. So I've done a little bit of digging in the pane in the bottom right hand corner there, and I found something that I think looks interesting, this appsend error response. So I am interested in requests to Apache that have ended up in an error. So they're the ones that haven't completed normally. So rather than taking my tail of the logs and, the whole kitchen sink in there, I'm going to take just the ones that are interesting to me, the ones that didn't complete successfully. So we have appsend error response there, which is what
Apache uses when it's sending an error response, as the name suggests. So I'll just see how we do for time. Yep, not too bad. Cool. So I'll just show you then what we have here with a basic example. It is unfortunately a little bigger than will fit on the screen at that size. But what we've done here is we have a probe, and it's a probe we're going to attach to APSend error response. So it's a U probe, user space. That's a little bit horrible there that I've had to do. The ask backwards thing is a genuine member of the Apache HTTPD request rec structure. I didn't make that up. That is a thing that I found there. So what I've done here, so the struct request rec is quite long. It's quite a long structure with a number of different things in there, and then pointers to other structures and so on and so forth. I was just particularly interested in this case in pulling out the request. So I just needed the top part there. So I've kind of cheated a little bit. Rather than have to include a lot of extra include files and that kind of thing, I've just done a quick and dirty definition of the structure there, but just the top part of it, if that makes sense. Some of those pointers there are not void pointers as such. They were pointers to other different Apache structures, but we don't worry too much about them. I'm just going to take the request there. So we go a little bit further down. Cool. So we are attaching a uprobe to Apache 2, and then it's attached to APSend error response, and the function that will be called is that one there. I can't remember what I called it. Probe APSend error response. So that's our bit of C code. And then we open the perf buffer, and then we are watching for data coming back from our probe. So I'll show you what that looks like in a second. Cool, so it is listening. Right, so I'm going to run my bit of BPF code there, so that should have attached as a uprobe to that particular function in Apache. So I'm going to do this curl that I know will generate an error. And then I've just extracted from there what the request was at a high level. I could potentially pull out more information there, so IP address and that kind of thing. But just to keep it simple, just pulled the request out there. So if we do something else, so that's a file that we know doesn't exist. What else can we do? So if we... so a request that completes successfully doesn't fire our probe, so we don't have to worry about them. Any request which is ending in an error is looking much more interesting, so we'll use our probe to take a bit more information there. I'm not saying that this should replace the logs and that kind of thing. They're useful too, but it maybe takes some of the demand off to get them there in kind of real time or real-ish time. We can maybe ship them a little slower, but then have this kind of information be extracted quickly and used to drive things like dashboards and alerting and graphs for security operations folks and that kind of thing. So that is our basic example. I'm going to tempt fate by trying to do something a little bit more, which is probably a really horrible idea, but we'll see what happens. So we've got this here. So I've imported a library there for Elasticsearch. Now I don't particularly have a strong leaning towards where you would want to put the data. There's no particular affinity between eBPF and Elasticsearch. It just happens to be somewhere at the moment that I like to put data. because they have something called Kibana that I'll show you in a second that you can get some interesting visualizations out of. But it does go to show it's quite quick. So we've got our more or less same program from before, but now we are taking the data, and rather than just printing it, we're putting it into a document and submitting it to Elasticsearch. And then this allows us to have visualizations, dashboards, that kind of thing. Also means that it's searchable. And also we can do kind of time window based reporting there. So we can say these are the top requests in the last 15 minutes. And then maybe these might look interesting. So if our rate of errors has suddenly shot up and there's a lot of these strange looking requests, then that could be something that we take action on. So if you look there isn't a lot to actually get that talking to Elasticsearch, which is another reason that I like to use it for this kind of thing. It's very, very easy just to drop a couple of lines of code in there, and then we can get that submitting. So let's see if this one works. Okay, that looks promising. So I'm just going to fire up my web browser. Wherever my mouse pointer's gone to. There we go. So this could get a little bit interesting in terms of me being able to see this properly, but I'm going to try and do my best for you. Cool. So we have... I know I'm not supposed to leave this spot. Just give me a second. Okay, cool. So that looks kind of about right. So if we go back into our terminal, so that's running. So now if I so I've got a couple of requests there. Can we see them? Absolutely no idea where my mouse pointer is. Okay, I was going to show you the data coming to there. It's a little bit awkward for me to do so, so I'm just going to skip over to hopefully something here that I've got working. Excuse me again. I want the top one, the bottom one, I want the bottom one. Is that the right one? Cool. So, taking the data, I'll just turn on refresh so that it will update for us. So I've taken the data. So with those couple of lines of code, I've... sorry, you want to say something?
Just wondering if you could zoom in.
Yeah, sorry, I should be zooming in, really. Let's blow it up nice and big. Cool. Better?
Yeah.
It's better for me too. Thank you for that. Cool. So what we've done here is to take the data that was being sent to Elasticsearch, and then we've used this thing called Canvas, which is part of Kibana, another thing from Elastic. So the data that we've submitted there, we can use it to draw kind of graphs and charts and that kind of thing. These are very simple to set up.
I was going to show a bit of that, but as the mirroring isn't working the way that we'd want it to, probably just leave it at that for now. But I'm just going to fire off another request into there, and then we can see that that gets picked up. Down there somewhere. There we go. Okay, so we have a few more requests that have gone in there, and then we can see that the dashboard is updated with more requests. We can see a count of how many of them are unique requests. That's not the best formatting now that I've zoomed in. I'm not, by the way, a designer by any stretch of the imagination. I'm more from the old school where people wrote horrible Perl programs and drew nasty graphs, which is what I've tapped into here, I think, in my subconscious. But hopefully that shows then that we can take this data, which is from an eBPF program, we can move that quickly back into Python, submit it off there to Elasticsearch or somewhere else, and actually start to do things with it, draw graphs, that kind of thing, the kind of thing that you could put in front of somebody and maybe generate alerts from if you wanted to. So, one more demo, and we can hopefully have some questions. I think we're still okay for time. So, move on to another one. Cool. So the idea here, I don't know if anybody caught Tom Nomnom's workshop this morning. You were in that one. Cool. So he mentioned in there that whenever you load a script on Linux, it's actually the kernel that is responsible for taking a look at that and deciding how to load it. So for this kprobe example, what I've done is or I'll show you in a second, is to attach a kprobe to load script. So that's the bit of magic in the kernel that kind of has a look at something, decides whether it is a script or not, and then goes ahead and sets up an environment and launches it. So if we have a look at this one, I didn't do, there was a basic example for this, but I thought we were kind of going over the same ground again, really. So I've gone straight to the one that will submit this into Elasticsearch. So I've got another one of those horrible looking dashboards for you in a second. But they can be much nicer. The problem is me. The problem isn't the tool. I've seen some lovely dashboards and visualizations. Yeah, it's just not the way that I think. So what we're going to do this time, so we have our kprobe on load script. So we're going to be passed a struct Linux bin param, one of them things, which is a structure describing the program that we're trying to load, essentially. So we attach that. What we need to do a little bit of checking. So one of the interesting things about when the kernel is doing its checks, you would imagine that it already knows that this is something sensible and looks a bit like a script before it's looking at it. But very often you can find yourself past a regular ELF file and all sorts. So this is kind of the first place where it does the checking. So I've mirrored a check that is in that particular function, which is just making sure that, in fact, in the proper check that's in the function, it checks for a hash and a shebang. But I'm just checking for the hash because by that point, somebody's trying to execute it. It starts with a hash, probably interesting. So we'll take that and then we'll submit that over to Elasticsearch. So this isn't perhaps an absolutely realistic example, but this is the kind of data that you might be interested in your environment. So are there new scripts that are showing up? So we could, in one Elasticsearch, submit data from multiple hosts, and then we'd have a searchable list of all the different scripts that were being run throughout the environment. We could choose to do some kind of deduplication there if we wanted to, but what we're taking isn't super heavyweight. So we're taking the PID, the inode number, because one thing is when you execute a script, you can maybe give a full path, or you can just // and run it within a directory. So you will see that when your probe is called, but the inode is something that tells us that this is definitely that copy of test.sh or whatever it may be in some fashion. There may be better ways to do it, but it gives us something that ties it back to an inode. It isn't unfortunately super easy to go from an inode to what file it points at unless you have some kind of a cache built up or maybe some debugfs type stuff. But it is something there that we could get quite easily and quickly, and then we can send that to Elasticsearch. So the whole thing there. So we're going to pass in a host name because we're kind of imagining that we might want to send this data from multiple hosts. And then if some new Linux malware comes out, Linux malware, I don't know if anybody knows, but a lot of it isn't super sophisticated, kernel module type stuff or anything fancy like that. A lot of it's in the real world, nasty Perl scripts and things that get dropped and call other Perl scripts and download who knows what so that you can become part of a botnet of some sort. So yeah, that's kind of what it looks like here again. Just go ahead and run this one if I'm in the right place still.
So that'll give you a log of every Perl script that's been read by the interpreter.
Every script which is being executed, every thing that starts with a shebang. So, you know when you have like a bash script and it starts with a hashbang bin bash. So underneath the hood, the kernel will load that up. So the structure that we get, it has the first 128 bytes of the script. Few other bits and pieces there that are useful. But yeah, from that we can see the interpreter. So we can see, is it a Perl script, Python script, bash script, or something altogether weird and wonderful? Yep.
So you could check off the ones that were valid and the ones that weren't, and look for anomalies.
Absolutely, yeah. Yeah, you could build up a whitelist of known scripts, and then if something new shows up in the environment, on any one of your hosts, if you're feeding them all into Elastic, which is just what I like to use, other people use different things, then yeah, you have then a search engine for unknown scripts in your environment, which could be a useful thing. And we've got it at very little cost in terms of lines of code. So let's just go again with one of these. So feed it some data. I think if we go into here, there should be a script to run. So the other thing that I did there, which you don't have to do, it's just a thing that I did, was to base64 encode it. That can be a sort of a decent format for working with data in. So then we just have a string, and we can see then differences quite readily. So we can see perhaps the parts that are the same and the parts that are different if we're doing some kind of comparison. So if we take another copy of that same script and call it test1.sh, and then we're going to run our test1.sh, just so we have a little bit more data when we pop back into Elastic. So if we go into... I'm not making this up, this is the longest trip to move my mouse pointer across. Oh, did we see it there? There we go. There we go. Cool, so we'll fire up another visualization. It is another horrible one that looks a bit like GD graph or something out of the 90s. But we can see here, so I've got some other data here. I've left this running in the background for a while in the past, and I can see other
scripts which are being invoked. And as the gentleman said, I could filter those out. I could say that they are known good. And then I would have a dashboard or some alerts that only related to unknown scripts. If we can. So I was having a little bit of difficulty seeing this before, but if we can get into here and just choose the sec logs. So we can see the two there. But if I expand time range, just check we're okay for time. I'm just going to have a couple of minutes for questions at the end. I'll just say the last 7 days. So we have more data in there. And if, for example, I was interested in Python scripts, do we have any of those? Perl scripts? There we go. So there's a Perl script there. So potentially we can have a look and see, is this known good? How do we categorize it? So that brings us to the end of the demos. I think we're kind of getting up towards time, but we've got maybe 3-4 minutes for questions if anybody has any.
Is there any way to profile for time or space, how long prototype?
That's a very good question. That isn't something that I've looked into too much. The things that I've read suggest that it's extremely lightweight. So when you have Kprobe originally, and I think in some cases still, it can be implemented with a breakpoint and single stepping. But now, as far as I understand it, it uses a jump, a kind of a trampoline to your code. So it's super negligible in that sense. Whatever you build on top of it might have a cost, though. When it comes to taking the data out in user space, you do need to keep up with it. So if it's kind of super high frequency, you may get to a point where the thing that's consuming it isn't catching up. So you can ask to be have something called there so you can take action. By default, it will just print out that you've exceeded a rate limit and then discard those. But yeah, I guess maybe if you're doing something very, very high volume, then you probably do need to be concerned with performance. A lot of the stuff I've been looking at is much lower volume. So I'm trying to put the probe in just the point where it's the data that I want. I don't want to take all the data like we did with log lines and then throw some of it away. I just want to go straight to the bit that's of interest and take it from there. But it is a good question. I would be interested if you come up with anything.
My question was more or less the same as that. So even if you're just looking for one specific thing and only outputting when you find it, you're still doing the traditional check every time, right? So is there any perceptible overhead to that in terms of running this in AWS? Do you have to beef up your instance size to be able to cope with the additional load?
No, not really.
Not seeing any noticeable.
I would say not. So if anybody didn't catch the question, we're talking about whether we need to kind of beef up the size of the instances if we're running in AWS or somewhere like that, and we want to use eBPF. I don't think so. So in the past, there was ptrace and that kind of thing, and that would be quite heavyweight. But with this, we are patching, essentially. So we're patching the function so that we get called. So if we put it in the right place, so for example, with the errors, the Apache errors, I'm just getting the ones that I'm interested in there with the errors. I don't have to do anything with every other request and throw it away or anything. It's just, if you get it right, quite surgical, if you know what I mean.
What if it's in a container?
This does work with containers. There are implications of this. So, in short, this works anywhere that you have cap sysadmin. You may have cap sysadmin in a container. This could maybe allow you to look at things that are outside of there. It might even allow you to
Look at other containers?
anything really. Yeah, I mean, so a container, in my mind, rightly or wrongly, is just a kind of a glorified sandbox. I hope I'm not going to upset anybody by saying that. But there is the shared kernel underneath. So if we have cap sysadmin and we can attach
a K-probe, then we're looking at the kernel across all the containers. So yeah, we can maybe see things that we might not want to.
So it seems, thanks for that, it's really interesting. It's a very powerful way of getting insight into really targeting something, specific behavior that you're interested in. But like the internal function names and things like that is really fragile, even with a Linux kernel.
Yes.
From what, even just between releases, it can all change. The official policy is it's only the user space interface that we are worried about changing. So I guess have you seen that a lot, and would it be a good idea to rely on other parts of the audit, like the audit subsystem, or most of the monitoring that you do? It's like a powerful way of targeting some specific behavior.
Quite possibly. So the question, if anybody didn't catch it, we're asking about these kind of APIs in the kernel and the fact that things may change between different versions. So functions may take different arguments, extra arguments, that kind of thing. One of the things that I've seen suggested in the past, and it was somebody from Netflix who suggested it. It wasn't Brendan Gregg, it was one of his colleagues. If you don't know Brendan Gregg, he's got really, really good stuff online about eBPF, much better than my efforts. So if you want to learn a bit more, definitely have a look at his stuff. But the suggestion was to use things like the LSM interfaces, so the Linux security module, which is maybe a bit more stable. You can pick things that maybe aren't going to change by your own kind of finger in the air. Does it look like something that's been that way for a while? But yeah, it is potentially tricky. You may need to rework things if something changes between versions, but hopefully you can reason out somewhere to put the probe that is fairly static, fairly unlikely to change.
Even worse would be if it changes and you don't notice, and then you might stops working.
That's the thing as well. Yeah, so I would say, be cautious. That's definitely one of the terms and conditions I'd say does apply to this. You need to make sure that you put the probe in the right place. I'd say also maybe don't try and put too much logic in the probe. Maybe lift the data out you're interested in and work with it elsewhere. I'm thinking that we're maybe a couple of minutes over on time. So I'll leave it at that. But if people are going on to the after party afterwards, or if you want to grab me outside, we can have a bit more of a chat about it. But thank you very much.